Guys. So in this video, I'm going to go over AMC 12B 2021 fall, problem number 12. Um, for n a positive integer, let f of n be the quotient obtained when the sum of all positive divisors of n is divided by n. For example, f of 14 equals 1 plus 2 plus 7 plus 14 divided by 14, which is 12 over 7. What is f of 768 minus f of 384? Okay, so for this one, I actually tried to do it in a more like kind of a fancy method, like a more efficient method. But I kept getting myself very confused and I kept getting a little bit mixed up on something. And it turns out that it's easier to just sort of work through the problem more like, straightforward. So if we think about the number 768, right? 768 is 2 times 384, right? 384 is 3 times 100, 68, 128. Is that right? 128. What's 28 times 3? 60 and 24. Yeah. So 384 is 3 times 128, and we know that 128 is 2 to the power 7, right? So 768 is 3 times 2 to the 8, and 384 is 2 to the 7. So if we think about it, like, all right, so we want to know the sum of all the divisors of 768, right? So we would be adding up all of its possible factors, right? Well, if you think about it, if we just look at the powers of 2, that's going to be pretty easy because that's just going to be like 1 plus 2 squared plus 2 cubed plus 2 to the 4 plus ... up to 2 to the, up to 2 to the power 8, right? Because like you basically just have 2's to work with. So it's just going to be like sum of powers of 2. But then remember, like, because you have this 3, you also have each of these factors multiplied by 3 as well. So if you think about it, you have the sum of the powers of 2 up to 2 to the 8 plus 3 times each of these numbers. So like you basically have this sum plus 3 times that sum, which if you think about it, if you add the sum plus 3 times the sum, you get 4 times the sum, right? So the sum of all the factors of 768 would be 4 times 1 plus 2 plus 2 squared plus 2 cubed plus 2 to the 4 plus ... 2 to the 8, and that's all over 768, right? And then we're subtracting, and like it's going to be the same exact thing for 384. It's just that instead of going up to 2 to the 8, it only goes up to 2 to the 7, right? But it's exactly the same thought process, right? 384. Now, what's kind of interesting here is because 768 is 2 times 384, we can multiply this fraction by 2 over 2, right? But then what's going to happen, so over here, we're still going to have 4 times 1 plus 2 plus ... 2 to the 8, 2 to the 8, over 768, whoa. I might keep writing it like that. Minus, and then it's going to be 4 times, now multiplying this by 2 multiplies each of these, so it's going to be 2 plus 2 squared plus 2 cubed, 2 to the 8, right, over 768, which notice how like all of these will cancel with like this, right? So all you're going to be left with on the left-hand side is 4 times 1, right? Because everything, the 4 times 2 will cancel, the 4 times 2 squared will cancel, 4 times 2 cubed will cancel, all the way up to 4 times 2 to the 8. Those will all cancel. So you're just left with 4 over 768, which reduces to 1 over 192. So kind of an interesting problem. The problem that I was having was like, I knew that 768 was 2 times 384. So I was trying to think of a shortcut to solve the problem, but I kept getting mixed up because I think I was like double counting some of the factors, because like just multiplying the factors by 2, some of the factors are going to be like repeats because there, because there's already a bunch of factors of 2 in the number. So yeah, it's hard to explain. So I think this is actually probably the easiest way to do it. Um, so yeah, so that's it for problem 12, right? In my next video, I will be doing problem, I believe 13. Yes, problem 13. All right, so I'll see you in my next video. Thank you.